All right, let's jump right into it. So we're on RN26 here. Make sure you read the chapter. The next two lectures, this one will be on the immune response, and there will be one more on cancer, which I haven't yet completely finished. So let's jump right into the to this lecture. All right. So since we're talking about the immune response and how our body can defend itself, I think it's quite pertinent to first of all think about what immunity means, and and what do you guys think? What do you have in mind? What do you think immunity is? What does it mean to have an immune response, to build an immune reaction, to have or not have immunity, right? So one way is to think about it as defense mechanism, um, and then how does the body actually defend itself? Well, one way to start thinking about an immune response within our body is to think of it as the ability of an organism, in our case, the human organism, to resist a particular infection or toxin. See, a lot of people jump to the conclusion that immunity has pretty much nothing to do with toxins, it's all about pathogens. And that's not necessarily true. A second thing that I think where a lot of us uh, make a mistake in terms of our thought process in thinking about immunity is to jump to the conclusion that is to not realize that there's a very big relationship between immunity, immune reaction, immune response, and inflammation. In fact, inflammation is part of an immune reaction, as we'll get to see. And so that plays pertinent role in a lot of the diseases we're seeing today, which now more and more are thought of as autoimmune because the body is unable to recognize self, and somehow some type of trigger in your body from the diet, from the air you breathe, from the furnitures you have, from the paint, from the carpentry, from a toxin that you've been exposed to leads to your body having a reaction and attacking itself. And so a lot of the conditions, including diabetes, is a form of autoimmunity. So it's quite a complex uh, series of reactions in the body, and we'll get into that as we go through. Let's keep this definition in mind as we go through. So, what does the immune system do, first of all, right? So, as I said earlier, it's the body's defense mechanism, it's the body's defense system, and it's designed really to protect against threats that we know, such as pathogens that come from outside of the body. And that could be anything from like a fungi, bacteria, parasite, viruses, and toxins as well, right? And so that's going to require our cells are going to have to be able to have the capacity or the ability to differentiate again between what that foreign particle is that you may be consuming in your diet. And remember, a lot of the functional medicine and people, as they're starting to see people are having symptoms, but we can't figure things out, they do an elimination diet. And one of the reasons is because people may not be allergic to carrots or allergic to gluten or allergic to, but they have food insensitivities. And so they may be eating certain grains that their body is reacting against. That is a huge part of what our immune system is doing. And so if we are eating foods that we have even minor sensitivities to, they could lead to triggering an inflammatory or pro-inflammatory response, which is not a good thing if it's chronic. If it's acute, that's a different story, right? And these our cells have to be able to have the capacity to differentiate between whatever this foreign particle is, including a toxin, including some gluten, celiac disease, including there's a very large list of things, and we'll see a couple of them, not all of them. There's too many to enumerate. But when the body's functioning normal, or when the immune system is functioning normal, that just means that we're able to identify, target, and get rid of these whatever these pathogens or these toxins in our body are doing without damaging our own tissue, right? And so the immune system really also has a complex ability to improve its defense mechanism by acquiring a sort of a memory of what is it that attacked us, so that the second time, if we get exposed to that pathogen or virus or toxin again, we may be able to mount a more quicker response. And this way, the immune system is constantly increasing its ability to respond to the environmental threats. And this is a really nice image that I found online, because it sort of shows you everything starts with the innate, inborn, with the non-specific immunity reaction, right? And that really happens within the first 4 hours. Inflammation kicks in right after the first immune response has taken place, and there's a large just series of cytokines that you can see in the big yellow box at the bottom that says pro-inflammatory cytokine release. Interleukin 1, interleukin 6, interleukin 8, interleukin 12, TNF, tumor necrosis factor, which is what was that for? Rheumatoid arthritis, they check that for that. And then notice how the CRP, C-reactive protein, which is a general inflammatory marker, goes up. Fever could happen, increased permeability, swelling starts to happen, and that's the calor, rubor, dolor of the inflammatory reaction, right? And then within that left side, you have the complement cascade or activation, which leads to a whole series of things. And that's sort of the innate. And then once that has been triggered, the more specific, acquired or adaptive. And I'm going to make a big, unless you guys can get that distinction in your mind between the understanding that adaptive or acquired is the same thing. Different textbooks use different words. Adaptive is acquired, acquired is adaptive, so it's very important to do that. And then this is where we talk about humoral or cell mediated, right? So T cells or B cells as we go through. So this slide sort of really gives you that breakdown really nicely, right? And then so if you see on the right side, the right upper area is T, and it's a cell mediated. Notice how it says Th1, and then down below on the right it says humoral immunity, and that's Th2, and there's quite a few others, and that's more of a B cell. So we need to understand the difference between cell mediated and T, and humoral and mediated and B, and these are very specific, and as opposed to innate, which is not specific at all. So let's jump right in here, and we'll start with, and I have a general slide that I'll show you a little bit to show you the difference between innate and acquired, or innate and adaptive. So what is innate immune system? It's where the body tries to recognize particular molecule or pathogen or something that the body doesn't have. So if you are gluten intolerant, lactose intolerant, something, and you consume that, and your body is unable to process it very well, then the body may be able to identify and recognize this molecule, substance, toxin as foreign, and then and it'll stimulate two types of innate responses. So you really need to understand this right here. When we talk about an innate immune response, we're talking about either an inflammatory response, as we said, from hour 0 to about hour 4. That's the inflammatory, right? Calor, rubor, dolor. And then also part of the innate is a general attack on these pathogens like phagocytosis, and that's more the white blood cells such as neutrophils and macrophages. So again, inflammatory response, phagocytosis, they're still very general, they're still non-specific, they're innate, but they're not specifically targeting, as for example some of the acquired or adaptive system does. So keep that in mind. And so again, there's two main innate immunity strategies. There's two overall. There's only two. When you think of the immune system, you guys need to think about there's two sides to it. And each of these two sides are going to be broken down. The immune system is broken down into innate, which is this slide that we have here that you're looking at, and it's broken down again into acquired or adaptive immune system, okay, which is what we're going to see right after this. And so we must understand that these are two very different ways of our body reacting. Again, I want to emphasize the importance. Oops, I misspelled acquired. Sorry, there should be a Q in there. Acquired or adaptive, if you hear adaptive response or acquired response, it's the same thing, okay, people? So don't make that mistake to think that they're separate. So what is the acquired or the adaptive immune system? Well, It's specialized, it's targeted, and it uses cells and throughout a process that ends up getting rid of the pathogen. So the ultimate goal is still the same: getting rid of that foreign substance, that trigger that is reacted, that is creating an autoimmune response, perhaps leading to arthritis or leading to whatever the problem may be. And this, just like innate, I'm going to go back to the previous one, and I'll show you innate. Oh, there we go. Innate is broken down into two: inflammatory and phagocytosis. Well, acquired reaction, the acquired immune system response, is also broken down into humoral or cell mediated. And you must understand, when we use the word humoral, we're talking about B cells. They're going to be triggered by the B cells. When we talk about cell mediated, we're talking about being triggered by the T cells, okay? Very, very important to keep that in mind. And so what I would emphasize on this slide is that the key difference between humoral and cell-mediated immunity, right, is that the humoral immunity is an antibody immunity. It's working with antibodies. It involves antibodies, while the cell-mediated immunity does not involve antibodies. You guys should understand that. Humoral involves antibodies. Cell-mediated does not involve antibodies, okay? So you must come to understand that. And humoral is really where the humoral, being the antibody mediated immunity, is mediated by macromolecules. They're found mostly in the ECF, or the extracellular fluid. They could be, like secreted antibodies or complement proteins as part of that cascade system, or it could be antimicrobial substances, or peptides, sorry. And then, so think of humoral immunity as it's named humoral because it involves the substances found in humors, which was the old Greek word that they used for body fluids. So it's mediated through body fluids, which includes the antibodies, right? And again, remember people, again, the key point: humoral, it contrasts with cell mediated because it involves antibodies, and are often called antibody-mediated immunity. So if you hear antibody-mediated immunity, it's really humoral, okay? And so acquired or adaptive, you must understand again, is also called a specific. So we like to really confuse the hell out of everybody and give 3-4 names for everything. So a specific immune reaction, an acquired immune reaction, and an adaptive immune reaction are all the same thing. But then we can break it down to is this specific immune reaction humoral or cell mediated? Versus the slide before this was innate, and innate is a non-specific. So pay attention to what I just said up to this point, because now we're going to get into breaking things down into small little areas. But if in the back of your mind you can keep the distinction between what immunity means, right, to get rid of a pathogen or a toxin somehow, and then that the immune system is broken down into innate and acquired, or call it adaptive or specific. So the immune system is broken down to specific, innate is non-specific and specific. Okay, so I'm throwing a lot of names at you here, and you should be writing these down and trying to get them into your head as what is what. The immune system is basically either non-specific, which is innate, which is right, non-specific, or specific, which is acquired or adaptive or specific. That's simple. The immune system, in general words, for what we need to know in this lecture, is broken down to non-specific and specific, or in other words, innate and acquired. And innate is broken down into the inflammatory and the phagocytosis, and acquired is broken down into humoral, cell-mediated. And even more important, as we get through these slides, the acquired ramification of the immune response is triggered into humoral and cell-mediated. Humoral is triggered by B cells. Cell-mediated is triggered by T cells, right? And it's the humoral that involves the antibody. It's an antibody-mediated immunity. So I'm repeating myself here, so you get the point. Humoral immunity is also called antibody immunity, and it does have assistance from the helper T cells. Now this can get confusing because we're trying to break it down into B and T, right? And so the helper T cells will play a role. We'll get into that shortly. But really, with the antibody-mediated immunity, it's the B cells that'll ultimately end up differentiating into plasma B cells that will end up producing antibodies against a specific antigen. Very different from cell-mediated. Very different from cell-mediated. So I'm going to repeat myself. There are two main mechanisms of immunity within the adaptive or acquired or specific immune response: humoral and cellular, right? Humoral is fluid through the fluid. It's activated or triggered by the B cells, and it'll help produce antibodies. With the cellular mediated, that will not happen. Cell mediated immunity, we're still underneath the acquired or the adaptive or the specific immune response. Cell-mediated immunity is the immunity that mediates mostly by T cell antigens, not T helpers, but T cell antigen receptors made by the thymus derived from T cells. There is no antibody involvement in cell-mediated immunity, okay? Cell-mediated immunity is the immunity, again, just reading this slide, I'm going to try to just repeat it, that mediates by T cell antigen receptors that are made by the thymus and derived from the T cells, which is why T cells play a role in cell mediated. And as the name implies, T cells themselves will specifically bind with antigens. So instead of releasing the receptors from like a cell body, for example, their ultimate goal is not to produce an antibody. Here finally is a slide that sort of breaks down the generalized two systems of the immune system, two responses, two ways that the body defends itself. There's the innate on the right, that is nonspecific. And if you look at the physical barriers, well, you always want to try to understand that the first line of protection for the body is the skin, the mucosal membranes, the saliva, urine, tears, stomach acid. These will all help. So, of course, if you give antacids to people chronically, their pH will change. We may be decreasing one of their physical barriers and breaking through. And so all of these physical barriers are extremely important. And I would like to point out there's something called MALT, mucosal associated lymphatic. There's books being written about that, but the mucous membranes play a major role. And taking a sidestep outside of the nursing world, outside of the NCLEX world for a quick second, you'll come to understand that from the mouth to the rectum is a very large tube. But anything that goes through the intestine and through the stomach and is sitting in there until it's been absorbed into the body is still considered outside of your body. It's still outside of your body. Now, if you have dysbiosis, leaky gut syndrome, or any of these problems where because of your bad diet or some other conditions that you may have, your inability to digest and absorb nutrients, and you end up having permeability of your gut, right? Things that shouldn't be coming in are going to be getting into your system, and your body will be triggering an immune reaction, which is why we think a lot of the chronic diseases we're seeing in the world today are autoimmune based, right? So when you start an IV, what are you doing? You're breaking the skin, you're breaking a physical barrier. These are all part of the innate systems, right? And phagocytosis or phagocytes together with the inflammatory reaction response, I don't know why. Well, the complement cascade may play a little bit more role of that. And as you see where it says complement cascade, it's just part of the immune reaction that enhances, that's why they call it complement, the ability of the antibodies or the phagocytic cells, the cells that chew and eat everything up, to clear the microbes and the damaged cells from an organism. The problem with, again, this complement cascade is, what do you think it does with a lot of the cytokines and the interleukins? It promotes inflammation, right? So we know, for example, omega-3s, DHA, especially in EPA, they're anti-inflammatory, right? And so we know there are things that are anti-inflammatory that are natural, but with the complement cascade, again, acute inflammatory response is a wonderful thing. You hit your arm, it swells up, it goes down after 2 weeks, you're good to go. But if you hit your arm again, it goes back up and it goes down after 2 weeks. And if you hit your arm again, and what you end up having is you have a chronic inflammatory response, which is what leads to a lot of the complications and problems. And but at the acute level, that complement cascade again promotes inflammation. It's a good thing because it attacks the pathogen cell membrane, and it's part of the immune reaction, the innate immune reaction. I should be specific. And this will not change throughout your lifetime. This is something that we all have, right? Unless you have an immune deficiency problem for one reason or another. And just remember, I don't know if you remember back in physiology and whatnot, microbiology, we talked about the complement cascade is basically biochemicals from like the C1 to C9. And I have to be honest, I don't remember them exactly. I don't think it's important at this point. But basically, it's just protein interacting with one another in a very specific sequence, complementary sequence that ends up leading to cell lysis and ultimately they with cytokines, they act like cytokines. They lead to inflammation, I guess is what I'm trying to say. So inflammation is a good thing, but not for people who have a lot of chronic diseases. That's all on the right side. Now on the left side, remember the immune system is either specific or non-specific. That's it. This slide right here is showing you the immune system in a nutshell. Now it gets very, very, very complicated, but all that complications is beyond our pay scale, beyond our scope of practice, but we really need to understand these basics here for sure. So on the left side, notice how you have acquired. And some people would have emphasized the word cell mediated and made that larger, or humorally mediated. But I like this slide because instead of just emphasizing cell mediated or humoral immunity, it's telling you, well, the acquired can trigger a response through the T cell reaction cascade or the B cell reaction cascade. When it's the T cell mediated, the cell mediated, not the humoral through the fluids and the antibodies, but the cell mediated, the whole T cells are going to end up being released into creating helper cytotoxic suppressor T cells, and those lead to the death of the body cells that are infected with a virus or a toxin or getting rid of it, versus the humoral, which is triggered through the B cell. It leads to the antigen, and ultimately it leads to antibodies, and it builds memory. So when you think of memory B cells, ultimately we're talking about humorally mediated immunity, and we're talking about B cell triggering, what ultimately creates a memory response that we can utilize if we're exposed to that same pathogen. Now, one thing that I find very interesting is that not only will the innate system lead you down the complement cascade leading to inflammation. I can't believe that the word inflammation is not even on this slide. It's hugely important, but where it says complement cascade, think inflammation. Well, that B cell immunity through a classical pathway will also lead to more of an inflammatory response. And again, inflammation is a wonderful thing, but not when you're having. Now, if you hit your thumb really, really hard and it gets really big and really purple, it'll take 14 days, just give it rest, ice, whatnot, elevate it, and it'll go down. But when you're eating foods that your body has some insensitivity to, you won't be able to see the inflammation. You won't be able to see it growing. When your thumb grows, it's wonderful because you can visualize it and you're like, wow, I know there's a problem. But if you're like using a hammer, if you eat processed foods, highly refined sugars, right, or grains, it's like a hammer that's hitting your gut. Ka-choom, 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 ka-choom. And so you end up having a acute inflammation reaction that just goes on and on and on and on. And unless you do the number one thing, which is to stop the triggers that are leading to that complement cascade continuously being triggered, no matter what you do, no matter how much medications you get, it's just not going to work. So that's extremely important to know. All right, I'm throwing a whole lot of slides in that are repeated. I like this one because it shows us a time frame. And again, this is breaking down the immune system. If you haven't gotten it already, I hope you do. Immune system is either innate or adaptive. And we use the word for adaptive, acquired, or specific, and for innate we use non-specific. And I like this one because it sort of shows you the epithelial barrier. Now, the epithelial barrier could be your skin outside, your skin where you start an IV, you're breaking through a barrier, or it could be in your gut, which ends up leading to you don't have enough probiotics or prebiotics, and there's a permeability starts to open up, and things that microbes shouldn't be going through start getting through. So the epithelial barrier could be in your gut, which is still considered outside of your body. It could be your skin. It's a macrophage. It's a neutrophil. So right, if the neutrophils are elevated, we know that the innate immunity is going to happen. And this generally takes anywhere between 0 to 12 hours, including a lot of the phagocytosis, right? The inflammatory rubor, calor, dolor will be the first 4 hours, but the whole overall innate immunity or non-specific immunity can last up to half a day. And then the adaptive immunity, again, cytokines, IL-6, you get the point, right? 8. All of these are triggers that end up leading, and we'll talk. I added a slide here with a little bit of a talk regarding COVID-19 and what we do know about that, and it has a lot to do with what they call a cytokine storm. We don't know if this for a fact, but I think it's interesting to think about it. So the adaptive immunity or the acquired immunity or the specific immunity is where we're dealing with the B and the different types of Ts, both the helper T and the cytotoxic. And that's where it takes longer, right? The innate immunity is a lot quicker, but the adaptive immunity takes longer, but it helps as well. So it's really important to keep these two in mind, right? So the innate immune system is considered also is the older sort of the evolutionary defense strategy the body has developed. And again, the innate, because of what I've been trying to tell you, here's an important point. You need to remember that the first line of defense is we're talking about innate, okay? And so defense mechanisms like the skin, for example, white blood cells, and we know that that's what we look at to see if there's an infection in the body. The macrophages, stomach acid, chemicals in the bloodstream, they're all part of innate immunity, right? Now, acquired immunity would be something like you get the disease or we give it to you through a vaccine, and that's going to initiate a primary immune response, which ends up in the production of memory cells. And so when we're exposed to the pathogen or the whatever it is that is triggering it, the memory cells are going to trigger a secondary immune response that will be much faster, right? And that's how we justify giving a lot of the vaccines, is because it's really triggering that adaptive immunity, that memory, so hopefully to build that memory response. So take a sip here. So you can see here again is another slide of we're not talking about anything different here. We're still talking about the immune system is broken down to specific or non-specific, or innate or adaptive. And cells of the innate immune responses, again, are the macrophages and the neutrophils. It's the phagocytosis. It's more of a general gobble. I'm going to engulf the pathogen after it's been identified. So we have to be able to identify it. That's where the innate immune system kicks in, right? And then the adaptive immune system, again, if you or acquired or specific, is the humoral or cell mediated. It breaks down into either one or the other. Okay. And this right now, this has nothing to do. This slide has nothing to do, I should say, with the innate. It's purely the adaptive or acquired response defense mechanism of the body. And again, it breaks it down to humoral and cell mediated. So I'm giving you multiple slides. They're very much repetitions. And you'll see the humoral through the extracellular fluid microbes end up triggering a reaction, and ultimately humoral antibodies help with the elimination of the microbes. And the cell mediated is more where the T cells or the cytotoxic and the T helper cells end up also activating a similar response, like the macrophage and microbial killing. And remember, the T cells are great when they're acute as opposed to chronic, because they'll release cytokines. But if you have a T cell that is just constantly just triggering, shooting cytokines, and that's not a bad thing. I mean, that's not a good thing. That is a bad thing. Same thing, different slide. Again, we're talking only about the acquired, okay? Only about the acquired or adaptive or specific. And so they have to be exposed somehow to an antigen, to something that they can defer and recognize as other, and it's going to lead down to either the humoral immune response, which is the sort of left side, activating the B cell. The helper T cell plays a little bit of a role, but it's mainly the B cell, which is going to give rise to plasma cells, memory cells, and it's the plasma cells that will secrete the antibodies that will defend against the pathogen and toxins in the extracellular fluid. Okay, so it's very important to have kidneys that work. It's very important to have livers that are working, because we know that the liver and the kidneys are organs of detoxification. Well, I'm sorry, organs of elimination, right? They help the body get rid of the things that are building up that we don't want to stay in the system for long periods of time. And so on the other side, on the right side, you have cell mediated. Again, an antigen leads to the activation of the T cell, which rises to the cytotoxic T cells that end up defending against infected cells. Now, I want you to pay very close attention to this slide right here, because you may see this question somewhere else, right? If somebody comes in and they have a high or elevated T cell count, for example, we want to try to understand that we may need to look at certain situations that the body's trying to fight off, and some situations are, yes, it could be transplant, but we're not going to go into that right here, but cancer cells as well. The active cytotoxic T cells can be triggered and elevated in patients that have cancer cells in their body, and that's very important for you to understand. Shall I repeat that? Very important for you to understand. Okay. So we know that for cancer, it's the cell-mediated cytotoxic T cells that'll be elevated and activated to fighting against that. I threw this in because I liked how it divided it into two sides. On the left side, up and bottom, they're both natural, and on the right side, up and bottom, they're both artificial. So if you look at just the top two ones, on the left you have natural active, and so the pathogen gets into your body, the immune system learns to fight the pathogen, antibodies remain in case of a reinfection, and on the top right you have vaccination, which is given, which leads to an active, it could be active or inactive pathogen, but anyways, we give it, it triggers an immune response that ends up creating the specific antibodies, and the pathogen is hopefully dealt with, triggered. But that's artificial because we're giving it, right? Those are the top two, right? One on the natural active, we just naturally get the disease, naturally fight it. The top right, we artificially inseminate or put it into the body to create a similar reaction. And then at the bottom, we have on the bottom left natural passive, bottom right artificial passive. So in the bottom left, you have natural passive, which we can get through it crosses through the placenta, through breast milk, and antibodies can go from mother to child. And so there's no necessarily, it's passive because so there's no exposure to the pathogen. The mom got it and was able to then build a reaction to it, and that defense mechanism passed on to the baby. That's a natural passive response system, as opposed to the bottom right, which is again not a vaccination, it's an immunization. It's passive, it's not active. Active is vaccination, artificial passive is immunization. Again, no exposure to the pathogen, that's why it's passive, and then it ends up helping the body with the antibodies to be able to fight through it. Okay, so notice that on the right, up and top and bottom, they're both artificial, but one is active because we're giving the vaccine, and one is passive because we're not exposing them to the pathogen. So hopefully that makes a good point. So I added this one in here so you could get to a point and understand that when we think of an immune system in the immune body, building up a defense system and attacking a pathogen or a foreign substance that we may have some reaction to in our body. And right now, everybody knows, gluten-free diets or lactose-free diets, but it's foreseen and foreviewed that in the next decade or two, gluten intolerance or lactose intolerance are just going to be two of 50, 100, 200 different things that we're slowly, and each individual may have reactions or slight insensitivities to certain foods. And there are now tests out there that we can do to see what our body is going to trigger a constant inflammatory reaction. So for our body to be able to fight these things off, we need to have organs of the immune system, organs within our body that can help us fight, such as the tonsils, the thymus, right, the T cells, the lymph nodes. The lymph nodes are all throughout the body. And unfortunately, still in allopathic medicine, lymph nodes are not seen as something very it is useful yet for any therapies. Naturopathic medicines, they do all kinds of treatments, natural substances, and they do lymph massages to try to, there's lymph combs that you can massage through, and the lymph system is like a sewer system. It builds up a lot of debris that we need to eliminate it. Unfortunately, in a lot of patients who have cancer, what they end up doing is, well, they just cut the lymph nodes out, or deal it like that. The spleen I want to bring to your reaction, because the spleen is very important. I'm going to repeat this in another slide so you'll know how important that is. But if you have a patient that had splenectomy and doesn't have a spleen, he's a very high risk for a lot of infection, because the spleen is an absolute important organ for building an immune reaction. The appendix, we really thought that it was nothing. We don't really understand it fully, but it does seem to be playing a major role, together working with the lymph nodes as well, bone marrow as well, and the Peyer's patch. These are all organs that help the body. I mean, these organs help for example, with white blood cells that are growing throughout the body. They protect pathogens, for example, and the immune system is one of the most important or critical systems, because without these organs, so if any of these organs are affected, you have to come to the understanding that you will not be able to necessarily mount a full 100% proper healthy immune system reaction, and we might not be able to expect or enjoy long-term whole body wellness. So all of these are absolutely important in building a good, proper, essential immune system response. The immune system often works with, remember, I like to talk about, there's the inflammatory response, right? And there's oxidative stress, and then there's an autoimmune. Those are really the three essential underlying causes that lead to a lot of the cardiovascular, MI, stroke, diabetes type 2, and which is an autoimmune. And so having a constant level of oxidative stress really can affect the body, and and the immune system will often work with oxidation to initiate the activation of immune cells, and antioxidants through diet help tremendously to complete this body's defense mechanism, by doing one thing, by helping the body sort of put out the battle, put out the flame, put out the complement system. Remember, complement system, we should always think inflammation. And so diet can play a very, very, very major role with the mucous membranes, and the link between the gut and the immune system is so vast, so large, so beyond my understanding and my scope. I read a lot about it, but be far beyond the scope of what we're trying to get through this lecture. I highly encourage you guys to go out and read about the links between the gut and our immune reaction, because it's extremely interesting. Again, the cornerstone of our immune response, our immune system, is to be able to recognize self versus non-self. Sometimes the elimination diet can help our patients, so that's something we can talk to them about. Just eliminate. There's a whole list of things that you eliminate, and then you add them one by one, and you eat every time you add one thing that you really like. Let's say you eliminated potatoes and grains and tomatoes and oranges and milk, and eggs, for example, and what you add in the thing you like the most. Let's say that it's tomatoes that you like the most, right? So you add in tomato for day 1, you eat tomatoes. Day 2, you eat tomatoes. Day 3, if you don't start getting migraines or upset stomach or bloatedness, then you can start adding a second one. And what will happen when you do the elimination diet is you'll now start to realize, man, I just ate eggs on my first day, and in the evening I'm starting to get a migraine headache, or I feel like so bloated. Well, there you go. Now you know that your body, and this is one way to sidestep having to pay major bucks to try to figure out what your body is going to have a reaction to in terms of the foods that we're ingesting. Again, I always emphasize one best way to get rid of a lot of the problems is don't eat processed foods, because anything that you're reading a label that says ingredients is processed in one way or another, unless it's, unless you read the labels and there's nothing there that really is processed, but that's hard to determine. Again, the elimination diet is really good because it can help us figure things out. So I have a quick little question here. You got a patient who has an immune deficiency involving the T lymphocytes, right? Because that's what T cells are, the lymphocytes. Which health screening should we do to and include as part of a teaching plan for our patient? Are we going to screen for allergies because the T lymphocytes is what are affected? Are we going to do a screening for malignancy? Are we going to do screening for antibody deficiencies? Or are we going to be screening for an autoimmune disorder? And remember, I talked about that slide earlier about on the right hand side, right, in the cell mediated, all the way at the bottom, the T cell activated, they lead to cancer. So if you think about that slide that I talked about, this is the second time it's coming up. You should get that into your head. We should be screening this individual that has an immune deficiency involving the T lymphocytes for malignancy, right? Again, cell-mediated immunity is going to be the one that's responsible for recognizing and destroying cancer cells. Let me repeat that. Cell-mediated immunity, like we saw 3 or 4 slides before this one, is responsible for the recognition and destruction of cancer cells, right? And then allergic reactions or autoimmune antibodies, those are mediated primarily through the B lymphocytes or the humoral immunity. Okay, so allergic reactions, autoimmune disorders, and antibody deficiencies. Remember, antibody, the cell-mediated, no antibody. So if you ever have that as a question, it's a big no-no. Allergic reactions, autoimmune, and antibody deficiencies will primarily be related to B lymphocytes or what we call the humoral immunity. Okay, does that make sense? So the 3 of these are mostly humoral mediated immunity, and only 1 is cell-mediated, and that's the malignancy. That's cancer. Okay, so keep that in mind. I threw this one in here. It does slightly complicate the things a little bit more, but not really, because the cells of the immune system can really be categorized as lymphocytes, neutrophils, or macrophages, like the monocytes, right? Lymphocytes, neutrophils, and macrophages are monocytes. And the lymphocytes is what we talk about. I earlier remember is the T cell, the T lymphocyte. The slide right before this, the man had the T lymphocyte. So lymphocytes are T, B, and the killer, the NK cells, right? And this slide here, they're all types of white blood cells, the lymphocytes, right? And then there also are major proteins in the immune system, and they work, through signaling, the cascading, like the cytokines we talked about, and through antibodies and the complement system. Those are mostly proteins that are involved. So what's the important thing on this slide? The main difference between the myeloid, which you see on the left, and the lymphoid cells, which you see on the right, is that the myeloid cells give rise to, look at what it says, red blood cells, granulocytes, monocytes, and platelets, whereas the lymphoid cells on the right give rise to the lymphocytes. And remember, what did I say lymphocytes are? T, B, and NK, okay, the natural killer cells. So again, the lymphoid cells give rise to lymphocytes and natural killer cells. There is another difference between myeloid and lymphoid cells, and is that the myeloid cells are released mainly to the bone marrow cells, whereas the lymphoid are related to the lymphatic system, right? So that sort of makes sense, lymphatic system and the lymphoid. And that's where a lot of those, once these BET the white blood cells that are on the right side, now it's confusing because the part of the myeloid have white blood cells as well, as you can see at the bottom there. And so the BET and natural, they'll end up having to be eliminated through the lymphatic system, which is why naturopathic medicine truly believes in doing proper exercise, movement, certain types of showers, using a comb, using certain supplements to help the body naturally get that lymphatic tissue back to flowing again, which is going to ultimately help the body detoxify. Unfortunately, allopathic medicine still poo-poos all of that as something that's non-scientific. Well, the science is there. It's just that some of us are either not trained or educated in understanding that, and that's quite unfortunate. I added this one here in brief. Really, myeloid and lymphoid cells are, again, they're 2 types of sort of, they're sort of progenitor, multipotent cells, which will give rise to cells in the blood. So they're the precursor that'll give rise to the cells that the previous slide told you what they become, right? And so what we need to understand is that myeloid cells are referring to the cells derived from the bone marrow, as I talked about before. Again, and the lymphoid cells are referred to the cells that are related to the lymphatic system. And so myeloid, again, granulocyte, the macrophages, they act quickly to kill infection, and they alert the lymphocytes, which in the previous slide we saw, and then the lymphoid with through the T cells, the B and the natural killer, they just float. They're going around the body. They're a little slower to react, right? They're more specific as opposed to the others, but they kill more specifically as well. They're slower, but they kill more specifically as well. I added this one in here so you could just so that you don't need to know this, but when we get into looking at these conditions, malignancies that are related to AML and CML, are the two main types of malignancies that are related to the myeloid cells, and the ALL and CLL, which we'll cover at some other point, are the two main types of malignancies in the lymphatic cells. So when we do cover that, just I'll remind you that we looked into the difference between the myeloid and the lymphatic cells. I found this here from the nursing education consultants. I like this slide. Because it in sort of picture forms at the bottom right, number one, foreign antigen invades, causing an antigenic response. And that ends up leading to an army that surrounds the foreign body. We've got them surrounded, and then number three, foreign body attacks, get them, and then I'm going to remember this guy. That's the B memory, and then four is the body will remember foreign antigen in case of future attack. Right? That's this really doesn't tell you very clearly which of the two, innate or adaptive, the system is, but if it's building antibodies, you guys can figure that out on your own, right? At this point. This one here, sort of, if you look at the body in the middle, is divided on the left into the immune system antibodies, which is slower, but it lasts longer. And notice that the individual is holding on to B and T cell, right? Which one would that be? Is that humoral or is that cell-mediated? Well, if you don't know, go back and get that because we've been going over that. On the right of the body, the individual there with those sort of mustaches, the inflammatory response. It's a lot faster, right? It's working through the fluids and the mast cells. It's the phagocytosis. It's the inflammatory reaction, and you should know if that's innate or if that's acquired, right? So that's one of the big things that I like to that I wanted to show this slide for. This here is for us to understand in terms, again, of innate versus adaptive. There's macrophages, which is part of that general first reaction, the phagocytosis. There's the dendritic, which is working with the antigen presentation. There's neutrophil, again, part of that phagocytosis. Then you have other cells like myeloid, eosinophils, basophil, mast cells, and they end up targeting antibody parasites, and releasing a lot of the pro-inflammatory mediators, the interleukins, and that cascade as well. Now, the natural killer cells try to break things apart and kill the infection, the pathogen. The complement system is where that cascade starts to form to ultimately try to destroy the microorganism. And the cytokines are just those proteins that are secreted by the cells, which are wonderful when they're acute, but horrible when you have chronic diseases. And ultimately that helps the body as well to mount a defense system. This is just a slide to show you, again, comparison between the humoral and the cell-mediated, what cells are involved in the humoral, B, what cells are involved in the cellular-mediated, T, right? Antibodies is humoral. The sensitizer, the cytokines, that reaction is more of the cellular, and memory cells may be present in both of them as well, right? So in contrast, the immune responses that are initiated through the specific antigen recognition by T cells, as opposed to the humoral, are going to be the cell-mediated immunity. So that's really important for you to understand. And we as humans really need both humoral and cell-mediated immunity. We need both. We need a balance between both of these systems. And a comparison, again, between humoral and mediated, again, we're only talking about specific acquired or adaptive response here, not innate. In humoral, it goes after bacterias, extracellular viruses, the RSVs and respiratory problems, gastrointestinal pathogens. and the cellular is more the fungus, intracellular viruses, chronic infectious agents, and tumor cells as well. Again, the key difference between humoral and cell-mediated immunity is that the humoral immunity is antibody-mediated immunity. It involves antibodies, whereas the cell-mediated immunity does not involve antibodies, okay? That's probably the fourth time that I repeat that. Now that we have a relatively superficial look at our immune system and how it's broken down into really two parts, and each part is divided into further two parts, we can start looking a little bit at problems of how the immune system is going to be altered. And there's three ways: incompetence or competence, right? And hypersensitivity. And so with immunocompetence, the immune system really is just recognizing or identifying or trying to inactivate the foreign substance. With incompetence, the immune system, this is important. You want to understand the difference between incompetence and hypersensitivity. I would like you to think of these two with two different words. I want you to think of incompetence as under-responsive, not able to respond as they should. Again, incompetence is an altered immune response where they're not able to mount the defense. They're under responding to it. And that would make so much more sense if we use the word under responsive. And then think of hypersensitivity as the exact opposite as incompetence. It is the immune system overreacting to foreign antigens. It's reacting against its own tissue. Okay, and that's where a lot of the chronic problems we believe are starting to affect a lot of the patients we're seeing in the body, right? So again, in order to describe what optimal immune function is, we have to understand what optimal means, and we have to understand that balance and equilibrium is what we're really trying to get here at with mounting a defense reaction. So if the immune system is in balance, the body is able to manage invading organisms with little or no side effects. Now, if the body, and this is where we're going into now with the altered immune response, if the body is imbalanced or has a dysfunction of the immune system, then we're more susceptible to infection, we're more susceptible to cancer, we're more susceptible to allergies, we're more susceptible to autoimmune diseases. We have to start getting that. We think the immune system is all about infection. Immunity is all about infection. No. Infection is just one small part of really what immunity is about. By this point, if you don't know that the inflammatory and pro-inflammatory response of our body that most patients are at, why do you think your homocysteine levels are high? Apart from the fact that we may be drinking a lot of coffee and eating high animal protein, which could lead to that, or you're depleted of B6 and B12 and folate, which could lead to your homocysteine. But it's your immune response is also playing a major role into affecting your homocysteine, just like it will with your C-reactive protein, right? So remember, if there's a dysfunction in your immune system, we're going to be more susceptible to not only infection, people. I want you to get this clearly. Part of this lecture is really to break that myth that immunity is all about infection. Infection is all about immunity. Immunity is all about infection. We're only talking about infection in this lecture. No, we're not. We're talking about cancer. We're talking about allergic reactions. We're talking about autoimmune diseases as well. Okay, so that's important. That's perhaps the most important thing on this slide right here. Now, the overreactive or hypersensitivity reaction breaks down into four types: type 1, 2, 3, and 4. And a couple of things that I want you guys to come out with this slide off the bat. Now, let me think about this for a quick second. I want you to know a couple things here. I want you to know that for people that are having allergic reactions, for people that have urticaria, skin issues like atopic dermatitis or wheal flare reactions or angioedema, reactions of that nature, rhinitis, asthma, or nausea, vomiting, cramping, these allergic, asthmatic, atopic dermatitis, skin-related urticaria type mediated reactions, you have to know right now, IgE or the type 1 reaction are going to be what? So you need to know, shall I say that again? You need to know that elevated IgE is a type 1 hypersensitivity or a type 1 overreaction of the body that's going to lead to these problems that I just meant. Also, one other thing I want to say also, elevated IgE is major reaction, especially in the intravascular compartments. It will lead to anaphylactic shock, anaphylaxis, type 1, IgE, hypersensitivity. That's one thing I want you to know. The IgM and the IgG can be both type 2 or type 3. They're more related to the cytotoxic, that's the tissue, cellular tissue destroying through the complement system, the sort of enhanced phagocytosis type things. Don't worry about that right now. The type 3 reaction, though, can be immediate or delayed, and that's like lupus erythematosus or acute glomerulonephritis or rheumatoid arthritis as well. That's more of an immune complex. That's the type 3. And I probably should have put the tumor necrosis factor here as part of that type 3 for rheumatoid arthritis. And then type 4 reaction, they're delayed, they're cell-mediated, it's a cell-mediated reaction. That's where the tissue damage is going to happen from the macrophages and their enzyme. And this one is where contact dermatitis and hypersensitivity to bacterial, fungi, viral infections, and even transplant rejections, that's type 4. So I think type 4, remember type 4 is contact dermatitis and transplant rejections. That's important to know for these hypersensitivity reactions. Remember, type 1 was atopic dermatitis and urticaria, right? Not contact dermatitis. a little bit of a difference there. This slide I just threw in there because I want you to keep in mind, I want you to understand, I want you to see how that IgG, initially the IgM goes up, and the IgG is a little bit on the lower side, but then on the right side, there's a secondary response. Look which one goes really high, goes really elevated. It's the IgG, and that is showing that the first exposure, IgM, is going to be measuring it at the short term, and the long, more second term is going to be IgG. So you need to know this. You need to remember that the IgG is looking at maybe secondary or reinfection, and you'll see this again in this lecture later on, so you should know what elevated IgG really is referring to, right? It's a subsequent exposure to the same antigen, so it's a reinfection of, let's say, a bacteria, for example, over relative time after the exposure, okay? And so what happens is that same antigen is going to induce a secondary response, and when that secondary response occurs, you will see large amounts of IgG produced in the secondary response. Hopefully that's stuck in and that's made sense for you guys. So a patient that has sore throat, rhinitis, elevated level of IgG, oh, well, here you go, IgG in the blood. Nurse explains that the patient's symptoms are most likely caused by, is it an allergy? A, is it exposure to toxic fume? B, is it an initial viral reaction? C, or is it a reinfection by bacteria? And you should know that IgG, if you keep that image in your mind, is a secondary reaction over time. So the proper answer is the IgG is the primary antibody found in a secondary immune response. What does that mean? A reinfection, a reinfection, a reinfection. So the answer is the bottom one, D, okay? All right, I threw these in here to give you an idea of this is getting a lot more into the details of the cytokine reaction, the pro-inflammatory reaction. A lot of this is very complicated. It's above my head. I don't understand this in a lot of details, but I can tell you that there's a theory out there that talks about trying to balance the body out between Th1 and Th2. Now, I will say that not too long ago, they discovered something called the Th17, which is related to the Th1 in the cytokines that they release. So Th17 also is playing a big role, but the balance initially, well, they call it the T helper cells 1 because it was the first T helper cell that was ever discovered, right? So what cytokines do the T helper cells 1, the Th1 cells produce? IL-2, IL-12, interferon gamma, and tumor necrosis factor. And tumor necrosis factor, again, well, here, let me put this in here. So Th1 cells mediate activation of macrophages, neutrophils. They're involved in cell-mediated immune responses and organ-specific diseases. They stimulate the production of IgG, which we just talked about, and some of the diseases that are related to Th-dominant immune responses are, as I said, as you should know through the tumor necrosis factor that I've mentioned multiple times, rheumatoid arthritis, Crohn's disease, thyroiditis, multiple sclerosis, insulin-dependent diabetes mellitus. These are all related with this cytokine storm and problems that are related to the Th1. The second one has Th or T helper cells 2. They're called 2 because they were found after the T helper cells 1, and they produce the following cytokines: the IL-4, interleukin 4, interleukin 5, interleukin 6, interleukin 10, interleukin 13. And what's important to understand with this one, again, is the T helper cells 2 stimulate the activation of mast cells, eosinophils. So eosinophils will be elevated, basophils, IgE antibodies, IgG antibodies, and it's more of a humoral response, and it's a systemic in autoimmune disease and chronic disease, very major role in a lot of the chronic disease. Again, inflammation and pro-inflammatory things, if acute, is very good for the body. It's a body's net. So when I ask, is inflammation good or bad, you already know that it depends. Inflammation is a very good thing. It's the body's natural response to, it's like saying, is plaque buildup in the body good or bad? Well, plaque builds up because there's damage to the inner lining and the endothelium of the cell, perhaps because of lack of nitric oxide and L-arginine, right? So in this case, we need to understand that it works slightly in a similar manner. And so some of the diseases that are associated with this, so again, chronic diseases just means that pro-inflammatory is happening over time, happening again. It's like hitting your thumb over and over again, not a good thing. Some of the diseases associated with the Th2 dominant immune response are asthma, contact dermatitis, or allergic diseases, okay? And remember, asthma and allergic diseases are always going to be IgE, and eosinophils, right? I found this on a Chinese website. I sort of liked it, how they broke down the type 1 IgE. Type 2 could be IgG or IgG, and the T cells are going to be the type 4, and that's the T cell mediated inflammation. And look at the bottom right, all the way at the bottom right, type 4, all the way at the bottom, multiple sclerosis, contact dermatitis, like I said before, Crohn's, rheumatoid arthritis, as opposed to at the first one, type 1, IgE, all the way at the bottom is allergic rhinitis and allergic asthma, right, as well. Those are the two most important ones for you to start understanding at this point. All right. So again, Th1, Th2, the key is obviously to have an optimal functioning and a balance between both of them. It was back in the 80s where two individuals, I forget their name, Kaufman, they were the first ones to identify the primary T helper cells, and they were the ones to label them Th1 and Th2. And both of these, T helper cells play roles within the immune system, many different roles. The Th1s, again, just to repeat here, fight against the intracellular pathogens like viruses, and the develop and maintenance of these, the defense, the body's ability to develop the autoimmunity seems to arise from an increase in these Th1 cells more so than the Th2. So, but again, when they're acute, great. When they're chronic, not so good. On the other hand, Th2 help the body fight the extracellular, as opposed to the Th1 was the intracellular, and they including many of the typical bacterial infections like what? Staph and strep. Th2 related to strep and staph. So an excess of Th2 can also lead to allergies and asthma as well. And so that Th1 and Th2 balance is really about balancing the cytokines. The cells should develop the ability to balance off the cytokines that the bodies are releasing, and again, these cytokines are what are influencing the immune response and whether we're tolerated or not. Again, the key thing is to have a healthy immune system for an optimal functioning is to have a balance between both of these reactions. Okay, so that's really important to know. So when we again talk about optimal immune response, is really a balance, an equilibrium should be really the target. So if we have If the immune system is imbalanced, the body will be able to manage invading organisms with little to no side effects. If we have an imbalance or dysfunction of the immune system, Th1 or Th2, cell-mediated, whatnot, humoral, then the immune system then will be susceptible to, again, infection, cancer, allergies, and autoimmune conditions, okay? And that's so one way I like to think about the imbalance or the dysfunction is really perhaps, again, this is a perhaps here, is that one of the causes of immune dysfunction, well, we know it's multifactorial. There's not one thing that's leading to the immune dysfunction, right? But what we do know, and this is not an allopathic, it's not a nursing term, it's a naturopathic term, they use the word toxic load or toxic overload. And again, that's why it's important to have the kidneys and the liver functioning properly and even the lymphatic system functioning properly to help work and reduce that toxic overload. And remember, in the previous lecture I gave, we talked about the EDTA or the chelation therapy. It helps overall with decreasing toxic load or the toxic overload. Remember, if it removes lead and mercury, it also helps bring back some elasticity to the endothelial lining of the arteries. That's a really good thing for cardiovascular disease and whatnot. So that said, what I guess I'm trying to say here is with an imbalance or a dysfunction of the immune system, that toxic load or overload is some amount of all the deleterious external influences on the body. And if you believe that your makeup, your hair dye, the food, pesticides, the furniture, new houses that you move into that have that new house smell, if you work in a carpentry, if you paint, if you smoke cigarettes, if you breathe the air, there's toxins out there. All of that leads to toxic overload, which affects your hypertension. And so we need to start to understand and link. Every time I repeat this, I'm not trying to repeat it for no reason. What you need in your mind, you need to link the concept of that total toxic overload is affecting your immune system. It is clearly affecting your immune system, which is why your kidneys and your liver can be affected and shut down, as I'll talk to you about with the cytokine storm. So again, what are the causes of immune dysfunction? I just told you. It's multifactorial, and everything that we're exposed to, whether we know it or not. And so I think the most important thing on this slide is at the bottom where it says after the ... if the body has an adequate supply of internal reserves. That's the micronutrients, the trace elements, the minerals. If we have optimal gastrointestinal function, that's including the pH, that's including that we don't have dysbiosis or leaky gut, that it's not permeable. If we have optimal nutrition status, right? So I want to make a really big emphasis here. We cannot say that vitamin C is good for COVID-19. We cannot say that garlic is good for COVID-19. We cannot say that pretty much any of these natural substances are good for COVID-19 because they're not. They're absolutely not. Because COVID-19 is such a new thing, there's no evidence to back up that any of these things are good. What we can say is that if we eat a anti-inflammatory diet, if we eat the proper foods that have phytonutrients and phytochemicals that are positive for the body, that build an optimal nutritional status, which could include eating garlic and sulfur containing foods, vitamin C, E, D, selenium. Selenium is essential for the autoimmune system. As well. Actually, I'll throw this in here right now. There's some research. God, I probably should have put this in for you guys out here. This is really important to understand. There's some research that shows for somebody who has HIV. Do you guys know the difference between HIV and AIDS? HIV, the immunodeficiency virus, ends up when it's more critical or more dangerous becoming AIDS. And one way we determine that is we do a blood draw and we look at your CD4 count. And if your CD4 count is below, which is part of that white blood cells, that defense mechanism that we're talking about in this lecture, if your CD4 count is below 200, then we can say, well, now you're in full-blown AIDS. And I've seen patients in the hospital that had a CD4 count of 1, 2, 10, 11, 12. So they were majorly into the AIDS at that point. Well, there's literature out there that says that selenium in some areas is a great lab to detect, see how your immune system is being built, because there was a relationship between low selenium and your CD4 count being low. Whereas if you consumed selenium, and the number one food out there in the market for selenium is Brazil nuts. So again, Brazil nuts can help patients. You just don't want to eat more than 6 or 7 of them a day, right? So again, back to this slide. If you have all of these optimal things in place, so vitamin C is not for COVID-19, but it can help build internal reserves. It can help build optimal nutrition. Garlic is not given for COVID-19, but can help the body get to an optimal nutritional status as well. Optimal liver function, proper hormonal balance, good genetics. Remember, epigenetics makes more of a effect on your phenotype reaction, as we've talked about in one of our previous class. And then low stress levels, right? Usually our ability to cope with most external influences, right? So when we talk about the immune system, we have to understand what are these external influences? Well, some of the deleterious or negatively affecting external influences on your immune system is, number one, nutritional deficiency. That could be malnutrition or just a poor diet. And if you're eating, processed, high refined sugars on a daily basis, your immune system will be weaker. There's no doubt about that. Pharmaceuticals, for example, antibiotic overuse, which could end up not only leading you to have C. diff and diarrhea, so it gives you an infection, by the way, but it gets rid of all of the good pre and probiotics that the body needs, and it affects your gut. So again, gastrointestinal dysbiosis, environmental toxins, xenobiotics, that's a world of studies. I mean, each one of these could be a lecture in themselves. Food sensitivity, which I've been talking about throughout this entire lecture, is really triggering your immune reaction as well. Liver dysfunction. If your AST and your ALTs are elevated, well, you may have poor detoxification and poor ability to excrete it. Hopefully, you guys are having, and your patients as well, multiple bowel movements every day, at least one. Right, I get tired of hearing, people, professionals, highly professional people saying, "Oh, what's your norm? Do you have 3, 4 bowel movements, or one bowel movement every 3 or 4 days?" Oh yeah, okay, well, good. No. We want to remove. We don't want to allow that stuff to sit inside your gut. Remember, if I have a plate with a piece of food on it, and I put that plate outside and I let it sit for a day, for a week, for 2 weeks, 3 weeks. After a while, mold, green, hairy stuff starts to grow on that. What makes you think that food in your gut that is sitting there, it's still outside of your body, but it's sitting there, that food won't grow mold inside your body? And all of that, if you have a permeability to your gut, is going to lead to increase of the IgE. It could lead to asthmatic reactions. So if you think there's not a relationship between poor diet and a liver dysfunction, or poor ability to detoxify, or good excretion, or on the contrary, an inability to get rid of your stools, big problem there, people. Big problem. We need to encourage water, encourage ambulation, encourage exercise, encourage fiber, psyllium husk, right? Then other deleterious external influences. Yes, we can talk about the pathogens, the viral, the bacterial, hepatitis, and all of these systemic infections that we see in the hospital. But so again, infection is just one minor, extremely important and dangerous, good to consider, good to keep in mind, and we can measure for these things in acute and critical care. But overall, infections are a small thing that lead to affecting your immune system. Elevated stress, we know there's a direct relationship to that. Lack of exercise, free radical damage. Smoking tobacco releases so many free radical damages in your body. And then again, hormonal imbalances lead to a lot of the problems we're seeing in the world today. So what substances, if we know what leads to modifying your immune system negatively, there's so many things out there. I'm just showing you an example of, if you go to a doctor who's properly trained in understanding this form of approaching health and trying to bring balance back to the immune system, things like zinc and selenium, right? Remember, selenium, usually if you go in and you have a thyroid problem, which is one of the organs that's very important for immune response to work properly. They'll just look at your TSH, but they won't necessarily look at your T4 or T3, right? And so it's very important, sometimes your primary doctor, they'll just look at your TSH. If it's within a normal number, they're like, oh, okay, you're good to go. Once you start having a lot more symptoms and you're down the line, then they may send you to an endocrinologist and you may get further labs like a T4 or T3 tested. But so selenium plays a major role in that conversion right there. Zinc, I have a little bit of a slide. Probiotics, we talked about essential fatty acids. These are all things that can help treat the causes of the immune dysfunction that we talked about on the previous slide. What about external toxins that can cause an immune dysregulation? Well, we have to understand that not only our bodies do we need to keep in proper condition to be able to fight what these external pathogenic factors are, but we also need to try to keep our world in a relatively healthy condition, because we know that on average in our industrialized countries, that's everybody, by the way, we consume several pounds of toxins per year, and that we get it through our food, we get it through pesticides. Glyphosate is one of the Roundup Ready, I tell you, killer, really bad. Don't be using that stuff in your backyard. Monsanto, and there's been lawsuits, and they've lost many of their lawsuits because of the evidence that scientists, through evidence, have been able to talk about how bad pesticides are. Prescription drugs, herbicide, toxic metals, petrochemicals, outgassing from plastics, chemotherapy is a toxin, right? And genetically modified foods. These are all just examples of external toxins that we can get to. Here's the slide that I just wanted to throw in there, because remember we try to balance the TH1 and the TH2. Well, TH17 now is linked to, look at that. Look at the diseases related to the TH17. I'll give you a second to look at it, starting from Alzheimer's, asthma, autism. You go down. I'm going to take a sip here really quick. So why do I show this here? Do we need to know this? Is NCLEX going to ask you about this? No, it will not. I will not either. You don't need to know it. What do you need to know? You're a healthcare professional, are you? You will be a healthcare professional, a registered nurse, right? And so we know, and this is something that you will now be able to keep in the back of your mind and have a conversation about with your patients, maybe for yourself or your family. We know that the rate of autoimmune disease conditions are continuing to increase worldwide. We know that. Again, autoimmune diseases, this is a lecture on immunity, and we know that autoimmune diseases are on the rise. Guaranteed, no doubt, right? We know that. And what research has shown us about this problem of autoimmune disease rising is that, well, this T helper 17 is actually helping us explain to a degree why there's some of this prevalence of these autoimmune problems that are rising in the world. And so we initially thought that autoimmune problems were primarily TH1, right? But now we're looking at TH17 because the cytokines are important that lead to, and again, so just look at that: rheumatoid arthritis, multiple sclerosis, Hashimoto's. Again, it's a chronic inflammatory disease, including asthma, for example, that have imbalanced T helper cells, and this is just one of them. So as healthcare professionals, but I just threw this in here. Look at where it says physical triggers response of the immune response. An infection, a toxin, it could be exogenous, could be endogenous. Food, peptides, allergens, medications. So we're showing you, right? And you do not need to know this other than the TH0 is sort of where everything starts, and then it leads to one of the other cytokines reaction that lead to, like the TH2 is the asthma or allergy, or the TH1 is autoimmunity and inflammation, right? Or the TH17 is fungi buildup and autoimmune reaction as well. So that's kind of important to know. And again, the really strong pro-inflammatory activities of the TH17 that I talked about in the previous slide really can explain a large number of the pathological features of things like systemic lupus erythematosus, or even it can induce vascular inflammation. And we know that when you have vascular inflammation chronically, it's a very, very bad thing, not very good. I'm not going to really go over this slide right here. I think it's not pertinent at this point. It just talks a little bit about how we're now starting to think that the controller of the immune system response is really the T helper cells and those cytokines that they're releasing into the body that then lead to an overreactive or an underreactive and incompetent immune reaction because of the release of these cytokines. So I hope you're starting to get the general concept in the back of your mind. And remember, this is a talk about immune reaction, immune response, but we must remember that we divide the immune system into innate or acquired, and it's the innate first, especially the first 4 hours with the calor, rubor, dolor, that lead to that inflammatory response. And the inflammation is a normal mechanism that our body has to quickly react to any damaged area and fix the problem. And what happens with that is during the process of inflammation, you may feel symptoms like pain, dolor, warmth, calor, swelling, edema, and redness, color, right? And then so the inflammatory response, or what inflammation is happening because tissues are being injured because of whatever that pathogen is. It could be toxin that we're exposed to in the makeup and the lipstick that you put on your lips. Like aluminium, for example. It could be bacteria, it could be trauma, it could be heat, any other cause. And then the damaged cells end up releasing chemicals, right? We've the interleukins, the cytokines, interleukins, cytokines, right? You must start getting the picture in your head, which include a lot of these histamines, bradykinin, prostaglandins, and these chemicals end up causing blood vessels to leak fluid into the tissues, which end up causing swell. And when the vessels start to become weak, ruptures can happen and plaques start to build up. So this slide right here is almost telling you right here in the nutshell why perhaps, when we do interventions to remove like an endarterectomy, we try to remove that big fat plaque up from your carotid artery, or with peripheral arterial disease, we try to go and do a peripheral bypass to remove again, or put in a stent and a balloon to try to pass it. All that is doing is trying to remove the plaque or open up the vessel to allow blood to perfuse the lower extremity. And a lot of the problem that we're seeing is right here, that chronic inflammation leads to a cytokine release into the blood, and that ends up damaging blood vessels. And when your blood vessels are damaged, that microvascular damage to your blood vessels, hopefully now things are slowly starting to come together conceptually in your mind, then the plaque starts to build up. We treat plaque as the enemy. We even treat lipids as the enemy. They're not necessarily the enemy. The plaque is just, again, like inflammation, a natural response that the body kicks into mechanism to try to patch up. It's like a Band-Aid so that this leaking of the blood vessels does not happen. This slide right here is extremely important for us to understand to a degree why a lot of the chronic diseases is starting to happen. And we're getting ready to wrap up here not too long from now. So let's look at a few factors of immune health. And we know right now that, well, 3 basic factors, we have a better understanding of the immune system and the organs that comprise it and what optimal function is. And so, how can we promote a positive health immune reaction? Well, 3 things: exercise, decrease those feelings of stress, and nutrition. No doubt. There's no doubt about that. And so a key point that I wanted to bring up is, in order to best promote immune health, it's really necessary to focus on multiple aspects of a healthy lifestyle, not just one, right? So, for example, if you neglect one area of your lifestyle, if you improve your diet, but you don't learn, or we don't learn how to manage our stress feelings, or we're constantly reacting with anger or whatnot, then even if you have the best diet, won't happen. If you have the best diet, you eat everything organic from whole foods, you eat absolutely no processed foods, but you have loads of antacids in your stomach and your pH is different, and you don't heal that leaky gut syndrome, you have that permeability, then you could eat the best diet and you still aren't going to be able to absorb all of the proper nutrients. So you have to heal the gut first. So there's a lot of things that are involved in this But as you go through as a healthcare professional, hopefully you have interest in learning about this and you start exposing yourself to research and reading books, and you'll start to learn a little bit better what's going on. And so it will be very difficult to be able to achieve optimal immune health unless we target it from multiple aspects. A couple things to keep in mind. I really want you to understand that, if somebody has a splenectomy, they're at really high risk for decreased immune function. They're not going to be able to mount a proper immune response. If you have elevated lab values like IgE and eosinophils, we're talking about atopic dermatitis, for example. Asthma, allergic, IgE and allergy. You should know that by now. And for example, when we have elevated IgM in the blood, what are we talking about? A reinfection, right? And again, the serum Ig and the eosinophils are going to be elevated again in what type of hypersensitivity? Type 1 hypersensitivity reaction, right? That's an allergic response. That's a type 1. You should start to get that into your head and keep that in your head because you might see it elsewhere at some other point. Okay, we're almost done here. So what do we know about, for example, this is extra information to throw in since we covered a lot of the immune system. What do we know about COVID-19 right now? This is not a fact. We don't know this, but we think it's playing a major role. Cytokine storm is believed to be wreaking havoc in the human body. And you could already see through that complementary cascade how the inflammatory response starts to happen through a tremendous release over time of pro-inflammatory interleukins, the cytokines. When you see that interleukin and cytokine interact, so when the infection becomes really serious, the immune system is going to increasingly activate and send high numbers of immune cells to the lungs to hopefully help impede the infection and restore the tissue. So they're sending all of these things in a proper reaction. But the problem with the cytokine storm is that the initiation of the inflammatory response, really what it is, it's inflammasomes, which are releasing, again, cytokines, pro-inflammatory molecules, cytokines, to the area in the case of COVID-19. And this can be incredibly serious, like with the SARS, for example, because the damage ultimately, again, acute inflammatory response is a very good thing. The inflammation is a good thing when it happens within the first 14 days to try to bring that down. But if we tell patients to stay at home for the first 14 days and only show up when they're having short of breath, they at that point may start to be involved in a chronic inflammatory response where the cytokine storms or stress is really affecting the lungs. And here I want to add in again that the cytokine storms, not only will they go and attack the lungs, but they can actually travel through your body and lodge in, guess where? Well, your kidneys, for example. And they can end up shutting down your kidneys as well, which is why some of the patients with COVID-19 end up having that problem as well. I just added that right there. If you look at the right, that image, tumor necrosis factor A, interleukin 1, interleukin 6, 1B, interleukin 2, interleukin, you get the point. These are cytokines that are not our enemy. They're good, but they're good when they're acute. They're not good when they're chronic, right? And so if you look at on the left, the majority of the severe cases of deaths from COVID-19 really result from a runaway of inflammatory responses within the patient's own immune system that cause what they're calling now a cytokine storm, and it's really difficult to interpret. So you start off with having a normal immune response that's triggered, leading to macrophages, which lead to the lymphocytes, which is the inflammatory reaction, which ends up leading to the destruction of the CoV-2 cells, releasing inflammatory markers, which end up leading to more damage, and that ends up leading to damaged lymphocytes. And at this point, you're now having an immune response that is out of control. And that inflammatory reaction, as it continues to increase, is going to only end up destroying healthy cells, leading to more acute lung damage, which is what we're thinking is actually happening in COVID-19. Now, really, I want to make an important point here in the next few slides, and we're almost done here, is when I talk about zinc or garlic or vitamin C or any of these things, we as healthcare professionals, we cannot say that vitamin C or garlic or all of these things are for the treatment or the cure or the reversal of COVID-19, because that's a lie. It's not true. what these things are good for is to bring the immune system back into a balance, but they're not for COVID-19. So just because there's no evidence linked between, let's say, garlic or zinc or vitamin C and this disease that we're seeing, this virus that we're seeing, it doesn't mean that we just should not consume these things. Eating oranges is not necessarily a bad thing. Getting some vitamin C in your body is not a bad thing. But as healthcare professionals, we have to be very careful with saying that there is a link between. But now I will say, New York hospitals and in China, every hospital in China was giving intravenous IV-C, and there's a lot of data that is starting to show that there is evidence that the people that had IV vitamin C did better than the ones that didn't. But again, as healthcare professionals, don't say things unless we have evidence to back it up. But again, that doesn't mean that because there is no evidence, they shouldn't be consuming any of these proper things. So let's take a quick look here, and we're going to wrap it up here with a few things that I want to cover really quick. We cannot control the virus necessarily, although the whole focus that we have right now out there is wash your hands, isolate yourself, stay home, and wait for the vaccine, right? Isolate yourself, wash your hands, stay home, wait for the vaccine. Those are all wonderful things. If we get a vaccine that proves that it works, wonderful. We do want to isolate ourselves. We definitely want to wash our hands. We want to wear masks. But all of that is talking about how we can, relatively speak, control ourselves against the virus. What we can control is the host, and that's you and that's me. And so what we do know is a proper diet will enhance your immunity, and a poor diet will decrease or impair your immunity. And you've probably heard a lot of talk about the role of zinc, for example, and why it should be consumed. And we know that we should have about 1.5 to 2.5 grams of it, and it's mostly found in the bones and the muscles. And this is important, we have no reserves of zinc in the body that are readily available to mobilize itself throughout the body. Therefore, a steady intake of it is really important to prevent deficiency. Does that mean that zinc is good for COVID-19? Absolutely not. COVID-19 is too new of an infection. There's not enough evidence to prove a link between zinc and COVID-19. That's a fallacy. Zinc has nothing to do with COVID-19. That said, we do know that zinc is really required for a functionality of over 300 enzymes. It plays a major role in the metabolism of lipids, carbohydrates, proteins, nucleic acids. Zinc is absolutely essential for normal T lymphocyte and macrophage activity. And if we know that there are no reserves of zinc in your body, that we can move to activate these T lymphocyte and macrophage activity, which we covered in this lecture pretty much in detail. So we cannot say zinc is related to COVID-19. What we can say is that zinc is absolutely necessary for normal T lymphocyte and macrophage activity, and we know that our bodies do not have reserves of zinc, therefore we should be consuming it. And zinc deficiency, even if it's borderline, can cause an imbalance between our T helper cell subpopulation. So I think that's really important to keep in mind, that no, zinc is not related to COVID-19, not at all. But just like COVID-19 is a brand new disease, most of the drugs that they're trying to sell as good and positive out there, they have about the same amount of evidence that we have in terms of whether zinc is related. So it's still sort of a, where different hospitals are experimenting with different things to see what helps. What we do know, without a shadow of a doubt, is that zinc helps in synthesis of collagen and in the thymic hormone production, for example, which is again involved in that T cell differentiation. So it's extremely important, and it can help. This thymulin can help prevent the overpopulation of the pro-inflammatory cytokines. Again, the same thing that I've been emphasizing over and over again. This is not a large list, but things that will help in boost and support the immune system. Ideally, we get it through whole foods. If that's not necessarily possible, then we get it through the supplementation. Again, none of this on this list is related at all to any specific virus, including COVID, but we do know that they have a major role in helping the immune system. Vitamin C, zinc, citrate specifically, D3 with K2, probiotics, liposomal glutathione, the mother of all antioxidants. the beta-glucans, omega-3 fatty acids, not the omega-6. Omega-3s and omega-6s are both very good fatty acids. The problem is the standard American diet, like hamburgers and meat and potatoes and so on, is really high in omega-6s. So if you have too much of the omega-6s in your body, again, it's a pro-inflammatory action that's going to lead to an already perhaps chronic problem the patient is having. On the other hand, omega-3s with the EPA and DHA, we know are anti-inflammatory. So that's a good thing to keep in mind. Elderberry, I just threw like 2 or 3 things in here, so you can take a look at where our science is. We know that elderberries contain bioactive compounds like flavonoids or phenolic acids that are really strong. Listen to the word, potent modulators of the immune response, of the immune inflammation. So that's why elderberry is sold as a really good anti-inflammatory, and it is shown to reduce interleukin 16, interleukin 6, tumor necrosis factor A and alpha, and then the reactive oxygen species as well. So oxidative stress. Second one that I threw in, the stinging nettle, great thing for the lungs, reduces inflammatory cytokine release. Remember the cytokine storm that is so dangerous for COVID-19 and a lot of the RSVs and other respiratory and other viral problems as well. We know that these reduce inflammatory biomarkers. Tumor, again, TNFA, interleukin 1, interleukin 6, and stinging nettle reduces the high specificity CRP, which is a inflammatory marker. Melatonin helps with, for example, with RSV and other viral infection, and it helps decrease acute lung oxidative injury. It helps decrease the pro-inflammatory cytokines. It helps increase the antioxidant protection, and it helps decrease inflammatory cell recruitment. So that's a good, you may not want to do this at the beginning if you're having an acute. You want the body to have that defense mechanism, but if you're going through it chronically, taking melatonin, for example, might be able to help you. And we're done. So take care of your body. It's the only place we have to live. I would like to add, let's take care of our planet, right? Because we know that if we treat it badly, it's only going to come around and snap us in the butt, and we're going to end up having a toxin overload. All right. Talk to you guys later.